Welcome to the lectures for Math 99 Week 9. I believe you have a test coming up next week. Check your calendar. Make sure you complete the required quizzes by the due date. So we said that this week we would start looking at adding and subtracting rational expressions with different denominators. And in the last lecture, we looked at finding the lowest common multiple of polynomials. If you need a bit of a review on that, make sure you go back and look at that lecture. So we have some steps here for adding and subtracting with different denominators. The first thing you want to do is find the lowest common multiple of the denominators. That means you're going to need to factor the denominators first. We're going to then multiply each expression by the missing factors. Remember at the end of the last lecture, I asked you to find the factors that were missing from each polynomial. We're going to do that. We're going to multiply the numerator and the denominator by the missing factor or factors. That means we're multiplying by 1. Remember, when you multiply by 1, you're changing the way a fraction looks, but we're not changing its value. Now we're going to have our numerator over a common denominator. We'll simplify if possible, because of course we know we should always simplify a rational expression. And if MyMathLab asks for factored form, make sure you factor everything. And finally, just for practice, we're going to find any restrictions, remembering that the denominator cannot equal 0. Now, before we look at an example with a rational expression, let's look at an example using numbers. We have this example using numbers, 5/12 plus 7 over 30. And we said back when we were working with numbers in week 1 that we wanted to find the lowest common multiple of the denominator. So we've prime factored 12. We prime factored 30. That should be an equal sign there. And remembering that we use all of the factors to their highest exponent, 12 needs 2 squared times 3. 30 needs a 2. We have a 2. It needs a 3. We have a 3. We also need 5. So 5 times 4 is 20, times 3 is 60. We also said that you would multiply by the missing factors. Here I see that 12 is missing a factor of 5, 30 is missing a factor of 2. So when we were adding and subtracting with fractions, we multiplied by the missing factor here, the numerator and the denominator. We multiplied by the missing factor here, the numerator and the denominator. Now you can see that both of these have a denominator of 60. So we've got our lowest common multiple of the denominators. In the numerator, we have 25 plus 14. If you've practiced this method for adding and subtracting with fractions, we're going to use exactly the same method working with rational expressions. Let's go back to our other paper. Okay, so we have an example here. We want to find the lowest common multiple of the denominators. That means I'm going to need to factor each of them. We have 3x plus 3, which is equal to 3 times x plus 1. We have 2x squared plus 4x plus 2. I see there's a common factor of 2. And then when I factor, I get x plus 1 all squared. The lowest common multiple of these denominators. This expression needs 3 times x plus 1. This expression needs a 2, so it's going to be 2 times 3. It needs 2 factors of x plus 1. So my lowest common multiple is 6 times x plus 1 all squared. What's missing? I see that I'm missing a factor of 2, and this expression has 2 factors of x plus 1. I only have 1 here. So it's missing a factor of x plus 1 as well. It's missing 2x plus 2. What's missing over here? It has the 2 factors of x plus 1. It has the 2, but it's missing the factor of 3. So remember, we're multiplying by whatever is missing. Now let's draw this out here. My first expression, let me get rid of that cursor there. There we go. Maybe this will make it a little bit easier to see. I'm going to write the denominators in factored form. Oops, that was a 1. So remember, we want these to be the same denominator. I'm missing 2 and x plus 1. So if I write that here as 2 times x plus 1, I can see now that this denominator is the same as my lowest common multiple. It has 2 times 3 and 2 factors of x plus 1. That means I also need to multiply the numerator by 2 times x plus 1, or 2x plus 2. I've just opened the brackets. When I write my missing factor of 3 here, I see the denominator has all of the factors, 2 times 3 and 2 factors of x plus 1. Put your equal sign at the left side there. So now my denominators are the same, and I can leave those in factored form. I don't need to open those brackets. I think most of the time my math lab will ask you to leave these answers in factored form. So I have 1 times 2x plus 2 plus 8 times 3. Now, remember, we're asking for factored form. I see that there's a common factor in the numerator. When I take out that common factor of 2, I see that there's a common factor that can be divided out. So we're left with x plus 13 all over 3 times x plus 1 squared. If we're looking for restrictions, remember that we're looking in the denominator. This is the only factor containing x. And we see that x cannot equal -1 because -1 plus 1 would give me 0 in the denominator. Let's try another one. What do you notice about question 2? I hope you notice that the denominators are opposite factors. That means I could write this as 6 over x minus 3 plus 7 over negative 1 times x minus 3. I factored negative 1 out of the denominator. That means the lowest common multiple is negative 1 times x minus 3. I needed a factor of x plus 3 here. We've got it. I need negative 1 and x minus 3 here. I've got it. So what's missing? Well, that first expression is missing negative 1. I have to multiply the numerator and the denominator by negative 1. I'm not missing anything in the second expression. It already has this denominator. So we have negative 6 plus 7 all over x minus 3, which equals 1 over negative 1 times x minus 3. I don't want to leave that negative 1 in the denominator. There are a couple of different ways you could write this answer. You could write it as negative 1 in the numerator over x minus 3, or you could write this as 1 over 3 minus x. Just open the brackets. I could have written negative x plus 3, but we prefer not to have a negative out in front. Either of these are fine. We have a restriction. We see that x cannot equal 3 because 3 minus 3 would equal 0. If that was a tricky question for you, I would suggest rewinding, writing it on a new piece of paper and trying it again by yourself. Let's look at question 3. We have a rational expression subtracting an integer. Remember, we could write this as 2 over 1. This tells me that the lowest common multiple is just going to be y plus 5, which means nothing's missing from this first expression. It already is over y plus 5. But if I look at the 2, it doesn't have y plus 5 in the denominator. So I have to multiply the numerator and the denominator by y plus 5. Remember that we're multiplying by negative 2. So when you open the brackets using the distributive property, be careful. So in the first expression, I have y plus 3 over y plus 5. And then opening the brackets, minus 2y minus 10. When I combine like terms, we have negative y minus 7 all over y plus 5. This is fine. If you want to, you could factor negative 1 out of the numerator and say that this is the negative of y plus 7 over y plus 5. Either of those is good. What about restrictions? Remember, we're looking at the denominator, and we see that y cannot equal negative 5 because negative 5 plus 5 would equal 0. So, can you give this one a try? Step 1, find the lowest common multiple of the denominators. That means I'm going to have to factor everything. Remember, I don't want to see your factoring work. You can do that on scrap paper. Just show me your factored form. Pause the video, figure it out. Now we need the lowest common multiple of our denominators. My first expression needs 2x plus 1 and x minus 1. The second expression needs 2x plus 1. We already have it. And x minus 2. Now we want to multiply each expression by what's missing. Don't forget your equal sign on the left there. So we see here, we're missing the x minus 2. So I'm going to multiply the numerator and denominator by x minus 2. What's missing in the second expression? X minus 1. So we have x minus 2 times x plus 2 subtract x plus 1 times x minus 1. All over our common denominator. And again, leave it in factored form. This is fine. So if I multiply these two, we have a difference of squares. If I multiply these two, we have a difference of squares. But we are subtracting all of this. Be careful. When you're subtracting, you have to subtract the whole product. Did you remember that? So we have x squared minus 4 minus x squared plus 1 all over our common denominator. And here's our final answer. What about restrictions? There's 3 factors in the denominator. That means, and they all contain x, that means there will be 3 restrictions. X cannot equal negative 1/2 or 1 or 2. How did we find them? Well, we know that 2x plus 1 cannot equal 0. We know that x minus 1 cannot equal 0. We know that x minus 2 cannot equal 0. I did have a page in the notes for you to do your rough work, your factoring, so use that if you need it. Here's another question. Why don't you pause your video, give this a try. So we've factored the denominators. We need to find the lowest common multiple. I need x minus 6, x plus 1, x minus 5, and we already have x plus 1. Now we need to find what's missing. If I look at these, I see that I'm missing x minus 5. Multiply the numerator and the denominator. If I look here, I see that I'm missing x minus 6. Again, multiply the numerator and the denominator. You don't necessarily need to write out this step here that I'm writing. You could go ahead and do the multiplication, open each of those brackets. And because we're adding, we don't have to worry about subtracting everything. I don't need to see your multiplication work. Multiplying these binomials you can do on another piece of paper. But I would like to see this step here. That way, if you make a mistake, I can figure out what it might be. So we have 2x squared minus 4x. What is this? Minus 40 plus 6 minus 36, all over the lowest common multiple of our denominators. Now remember, my math lab is probably going to ask you for factored form. And if I look at that numerator, there's a common factor of 2. Make sure you write this in factored form if that's what's asked for. Now there is a trinomial there. It cannot be factored. I'm just making sure of that. If I'm wrong, you can tell me. But here's our answer in factored form. What about the restrictions? There are 3 factors in the denominator. That means 3 factors in the denominator containing x. That means I will have 3 restrictions. Why don't you pause your video and give this one a try? Okay, we've factored the denominators. We see our first expression needs 2 factors of x minus 3. The second expression needs x plus 3. And we already have a factor of x minus 3. So what's missing? Well, I'm missing x plus 3 here. What's missing from our second expression? I need 2 factors of x minus 3. I only have 1 here. So we're missing a factor of x minus 3. And of course, we are subtracting. So we have x plus 3 times 3x minus 2, subtract x plus 1 times x minus 3, and because we're subtracting, we know we need to subtract this entire product. Have I mentioned that this would make a very good test or exam verifying question? It definitely would. So all over our common denominator. And again, I don't want to see your multiplying work here. Just your final product. So we've made sure to subtract that second product. Now we can combine like terms. We want to make sure that this is in simplified form, because if we're being asked for factored form, I need to know if I can factor the numerator. I need 2 numbers that multiply to a times c and add to b. If I think about the factors here, I'm never going to get a 9. So the numerator cannot be factored. This is our final answer. As for restrictions, I see that x cannot equal 3 or -3. Remember, for your restrictions, we are just looking at the denominator. One more question to practice. Pause your video, see what you can do. So the lowest common multiple needs x minus 5, x plus 3. We already have x minus 5 and x plus 4. What's missing? Here I can see that we're missing x plus 4. Here, x plus 3. And since we are subtracting, I know I need to be careful. Don't forget your equal signs. Now this extra set of brackets that I draw here in red are actually not necessary. Oops, in red I said. But they are a good reminder that we want to subtract that entire product whenever we have a minus sign here. Oh, I get a little tired of writing that denominator. I don't know about you. So we have x squared plus 2x minus 17 all over x minus 5 times x plus 3 times x plus 4. The numerator cannot be factored any further, so this is our answer in factored form. We have 3 restrictions. There you go. Let's leave this for this lecture. We'll come back and finish up week 9 with complex rational expressions.